And welcome, students, to our first actual lesson of Programming 2. We're finally getting into some concepts now that we've went through our quick review. So we're going to first talk about inheritance. Let's jump into some inheritance basics, starting with that of derived classes. So getting started, one of the main techniques of an object-oriented programming language is a concept known as inheritance. Now, inheritance means that a very general form of a class can be defined and then compiled. So it's a generalized thing. Now, later on, we'll talk more specialized versions of a class that can be defined by starting with an already defined class and then adding more specialized things like instance variables and methods. Now, the specialized classes are said to inherit the methods and the instance variables of the previously defined general class. So let's take a look at inheritance then. Inheritance is a process by which a new class, also known as derived class, is created from another class, which is called the base class. And we'll look at some examples here in just a minute. A derived class automatically has all the instance variables and all the methods of the base class. So let's just say you had, instance variables for name, age, and grade. The derived class will automatically inherit name, age, and grade from that base class. And it can have additional methods and or additional instance variables. So the derived class might have variables and stuff that don't exist within the base class, which is perfectly fine. The base class doesn't need those specialized instance variables or methods. All right, so let's start looking at derived class. So suppose we are designing a record-keeping program that has records for salaried employees and hourly employees. So two different types of employees. Now, obviously, how we could do this in the past, we would make a class for hourly employees, deck everything out, make a one for salaried employees, deck everything out. However, with inheritance, you'll notice there's a natural hierarchy for grouping these types of classes. So these are all classes of people who share the property of being employees. So no matter what, employees is a type, and they're all going to have certain things. So for example, employees that are paid an hourly wage are one subset. Obviously, the other subset would be then the salaried employees who are paid a fixed wage each month. Now, although the program may not need any corresponding type to the set of all employees, thinking in terms of more general concepts can be useful. For example, all employees have a name and hire date when they start working with the company, and the methods for setting and changing names and hire dates is going to be the same, whether they're salaried or hourly. So that in mind is going to help us design a general employee class. Because, for example, even without you don't know all this stuff, you know, well, they're going to have a name, for example, and you're going to have when they started with you. That's the hire date. That's two properties, two variables that you could make right there that could be therefore shared across both the salary employee and the hourly employee. Now, the classes for hourly and salary employees may be further subdivided as diagrammed on the next slide. So let's take a look at that. So here we have an employee. So employee would be the base class. All right, that's where you're going to have things like name and start date. From there, I can take and break it down into either hourly employee or a salaried employee. All right, so let's take a look at salaried employee first. Well, with an hourly employee. With an hourly employee, you can either be full-time or part-time. And then, of course, you'll have the corresponding properties in there. A salary employee, you might have different kind of things, such as, it could be an executive, so that's like administrators, or you can have technical staff, would be like maybe your engineers, technicians, clerical staff, whatever. It can be broken down to multiple different fields. We could look at this in multiple different ways based upon multiple different settings. It just really does depend on how this gets broken up. So within Java itself, you could define a class called employee, which we just saw, that includes all employees. All right, so that was the salaried employees and the hourly employees. And then we could use that class then to define classes for hourly and salaried. We could then in turn use classes such as hourly employee to define classes such as part-time hourly employee and so forth. Again, referencing back to that diagram that we were just looking at. Now, the class employee is going to be in the course materials, as will all the necessary subclasses that I mentioned as we move through this. Now, what's interesting about the employee class is that we can use to create a class for hourly and a class for salaried. Right? So we're going to be able to extend that class to give the properties to make those various different subclasses. Now, it's legal to create an object of the class employee, but our reason for defining the class employee so we can define derived classes for different kinds of employees. So we could just technically create an object called employee and give that properties. But because we want to break it down and differentiate between a salaried employee and an hourly employee, we can go ahead and use this approach right here. All right, so let's first talk about the base class. Now, hourly employee contains the definition of a class for hourly employees. An hourly employee is still an employee, so we define the class hourly employee to be a derived class of the class employee. Because remember, in that hierarchy, it was underneath it. A derived class is a class defined by adding instance variables and methods to an existing class. So the existing class that the derived class is built upon is called the base class. In this example, our base class is employee. In our example, as I just mentioned, employee is the base class and hourly employee is the derived class. As you can see in the class, the way we indicate that hourly employee is a derived class of employee is by including the phrase extends employee. So that's going to be our key term. When you see the word extends, that means it's a derived class on the first line of the class definition. So for example, here I have public class, hourly employee extends employee. All right. And that's how we know one class is derived from another. Obviously, you could probably also have, if you're looking at, let's say, a part-time employee, you could have something in here that says like public class part-time employee extends hourly employee. All right, subclass and superclass are very important to mention. A derived class is also known as a subclass. And we've kind of thrown this term around a little bit already, in which the base class is usually called a superclass. So if you're looking at the hierarchy, back when we had that diagram, if it's below, it's a subclass. It's above, it's a superclass. All right, just like subscript and superscript, it's the same kind of concept. However, we're going to use the terms derived and base class simply because it's a little bit more formal, and what Java is a little bit more used to using. Depending on your programming language, they might use sub and superclass. It's just another terminologies for the same thing. Now, when you define a derived class, you give only the added instance variables and the added methods. You don't need to copy and paste anything over from the previous class. You're only going to have whatever's new. So if you're really only adding one new method, let's say, then the only thing that's going to show up in that extension, in that class that you've derived now, is that new method and whatever corresponding variables will be needed for it. So for example, the hourly employee has all the instance variables and all the methods of class employee, but you do not need to mention them within the definition of hourly employee. And I'm just going to pause right here and go over to Eclipse just to kind of show you these because I haven't really shown you any yet. Here is employee right here, and you can see we have public class employee. So here's my class right here. I have public employee, so here's my constructor. I also have public employee original object, so this allows us to create one. And we have our string get name, get hire date, set name, set hire date, string toString, and equals. All right. So that's all our methods right there within the employee class. So no matter whether they're hourly employee, everyone is going to have these methods and these variables. Now let's look at an hourly employee. With an hourly employee, see it says public class hourly employee extends employee, private double wage rate, private double hours. So we're having to keep track of how much are they being paid per hour. Right? Then we have this constructor here, hourly employee, super. You'll notice there's a super call here. Wage rate equals 0, hours equals 0. What this super means right here, I just want to point this out. Super means that it is calling the properties of the superclass. Right? So if we look down here, you'll see, for example, hourly employee string the name, the date, double the wage rate, double the hours. Super, the name, the date. All right, this means what do you want to pull down from that superclass? All right, so here our superclass is employee because this is an empty parameter. I'm not pulling down anything from the superclass. Now this one, because I'm pulling down the name, the date, you'll see that string the name and date the date. So it has to pull down a string name and a date object and plug them into here. Right? Down here, you'll see we have our original object, so it's pulling in the original employee object, etc., etc. We have double get rate, double get hours, so these are two accessor methods right here. We have get pay, set hours, and of course set rate. So you can see, though, there are no methods or variables that are duplicated from within inside of here. You will see that we do have string the name, string and date the date, which matches what we have here, string the name, date the date. All right. Just for your peace of mind, when you go to extend a class, you'll probably want to keep these the same, because the reason that you keep them the same is because it's an extension of the previous class. All right. So it just kind of makes your life a lot simpler when you do that. Now let's go ahead and jump back into the PowerPoint here. Now, if you take a look at that, you'll see that every object of the class hourly employee has instance variables called name. But you do not need all right, I think I missed a word there, but you do not need to specify the instance variable name or the instance variable hire date, because I think hire date got omitted here. So instance variable name and hire date. All right, so you don't need to include in the class definition of hourly employee. As I pointed out here, these variables right here do not exist here, but yet they can be used by this class. The class hourly employee, or any other derived class, is said to inherit the instance variables and methods of the base class that it exists. So I don't have to go and redeclare them or anything that, or reinitialize them, because they already technically exist. All right. For this reason, the topic of derived classes is called inheritance, because you're inheriting it from the previous class. All right, so let's continue talking about inheritance. Just as it inherits the instance variables of the class employee, the class hourly employee also inherits all the methods. All right, as I already pointed out, you'll see that there's no methods that correspond from one to the other. So the class hourly employee inherits the methods get name, get hire date, set name, set hire date, all from the class employee. So, for example, let's suppose you create a new object of the class hourly employee as follows. Hourly employee Joe equals new hourly employee. Then the name of the object Joe can be changed using the method setName, which the class hourly employee inherited from the class employee. The inherited method setName is used just like any other method. Joe.setName, Josephine. Now the class salary employee is also derived from the class employee. So let me just pop over real quick. And here's salaried employee. Move that over. And you can see that it also extends employee. We have a private double fold salary, which is annual. Here is our constructor, and you can see it also calling the super, and it's by default setting salary equal to 0. Right. Down here you have the salaried employee, which gets the name, date, and a salary amount. Down here you have salaried employee, original object. You have double get salary, double get pay, set salary, and your toString and equals methods. All right, the class salaried employee inherits all the instance variables and methods of the class employee, just like we saw in hourly employee, where it inherited the instance variables and the methods. Salaried is also doing the same, because you notice it has that keyword extends. Inheritance allows you to reuse code, such as the code in the class employee, without needing to literally copy the code into the definition of the derived classes, such as employee and salary employee. This is really great because I don't know you, but it'd be super annoying to have to copy and paste the methods every time when I want to reuse them for these classes. So having that ability is really, really nice. All right, let's just real quickly, one of our kind of our last concepts to discuss is that of parents and children. Now, the base class is often called the parent class. All right, we've already mentioned it's also called the superclass. This is just yet another name that you might hear. This is kind of important to know, because you ever start talking about hierarchy, they'll talk about parents and children and roots and stuff like that. You want to start getting used to hearing some of that verbiage in case if you ever come across it. A derived class is then called a child class. All right, because in hierarchy, in file hierarchy, a lot of times the folder or file that comes up, in the order, if you look back at the chart that's above, that would be called a parent, and what comes below it is a child. Just like if you've ever looked at a family tree, the parent is on the top, and then the children are underneath. All right, this analogy can be carried one step further, that a class is a parent of a parent of a parent of another class, or some other number of parent iterations, is called an ancestor class. So if it's more than the immediate parent, so if we look back at that diagram, Let me just kind of flip back real quick here. Lightning speed. All right, that's fair. All right, if we were to look, let's see, at this clerical staff right here, the parent class would be technical staff. The child class, of course, is clerical. Right? Or even we just say, hey, let's look at technical. Well, the technical staff, the parent is salaried employee, the child is clerical staff, technician, engineer. If I want to look at employee from technical staff, that would then be called an ancestor because it's not the immediate parent. Only the one that's immediately above it is called a parent. If you go anything farther than back, then you have a child. So let me just go ahead and I'll just jump forward here. There we go. There's a jump. There's a button I could click. All right. As I mentioned, ancestors class. Now, if class A is ancestor to B, then class B is often called the descendant of class A. So descendants are the opposite way of ancestors. All right. And that kind of wraps that up. I just want to kind of quickly flip over to Eclipse here and just run the inheritance demo here for you. And you can see that when we start this up, we have our hourly employee Joe, we have the new hourly employee, Joe worker, new date, January 1st, 2015, 50.50, 160. Right? And what that does, it says system out of the print line, Joe's longer name is Joe.getName, and of course I can fix that to a capital J. Right? Changing Joe's name to Josephine. Just reround there. And those lowercase bother me. There you go. Joe's record is as follows. Josephine, January 1st, 2015, $50.50 per hour for 160 hours. Right? And that's all done from the various methods within the class. We have a getName method right here. We also have we just output Joe, which is just outputting whatever the object is. In this case, Joe is the name, the date object, the rate, and that's about it. All right. So a nice, quick, and easy one here for you folks. Hopefully it's not too confusing. Again, this is a pretty powerful concept that we have here. So I think that's going to be it for today. Until the next time.